At Quezon and in other critical operations in Southeast Asia, free world forces have been aided by a knowledge of the enemy's location and movement. Much of this battlefield intelligence has been developed by the employment of an integrated detection surveillance system, which performs day and night under all weather conditions. This system has enabled our forces to direct timely countermeasures against concentrations of enemy troops and supplies. This surveillance system is based on the concept of utilizing an electronic sensing or eavesdropping device which can be monitored from a remote location. We are, in effect, bugging the battlefield. The communist aggression against South Vietnam has been supported by an overland flow of men and supplies from North Vietnam by way of several infiltration routes. Hundreds of gasoline and diesel cargo trucks operate on a complex network of roads in communist-controlled areas. The dense jungle canopy overhead, the complex network of roads, trails, and footpaths, the constantly changing weather conditions, and the rugged terrain make the detection of this infiltrating traffic difficult. To assist in solving the problem of reducing infiltration of enemy personnel and supplies into South Vietnam, the Department of Defense initiated a program to develop an anti-infiltration system for gathering intelligence and by its use impeding these movements. It is based on implanting patterns of sensing devices which electronically detect earth vibrations or sounds caused by moving vehicles or troops. These sensors are monitored by ground troops and airborne personnel. In practice, both air and ground support often are used in the same military operations. But for the moment, let's consider the two means of support separately. First, the system when supported by air. This system is used primarily in inaccessible areas. As an enemy vehicle or troop detachment moves along a route which is under surveillance, ground vibrations or sounds activate one sensor after another. These sensors transmit identity codes and sometimes actual sounds of movement by self-contained radio transmitters to special manned or unmanned aircraft which orbit the sensor fields, monitoring the sensor transmissions. Automatic relay equipment aboard the aircraft relays the sensor signals to an infiltration surveillance center. There, center personnel analyze these activated sensors. Then, in correlation with other intelligence, determine the gross size and types of targets with the direction and rate of movement. Once identified, targets are reported to the Airborne Command and Control Center and to Task Force Strike Operations, which assigns attack aircraft for a strike. Strike reports are analyzed by the Infiltration Surveillance Center for effectiveness and for future planning. Another method of utilizing the system is by hand emplacing the sensors in areas accessible to ground troops. When ground vibrations or sounds activate sensors, the transmitted signals are monitored at ground sites by personnel using portable readout devices and relay where required. When targets are identified and their movements plotted, a request is made for fire support. Air support also can be directed to attack the target. Let's look at several of the sensors which have been developed for this program. One type is the seismic sensor, which, when activated by ground vibrations caused by the passage of vehicles or personnel, transmits an identification code by radio waves to a monitor. This, for example, is an air-delivered seismic intrusion detector, or ADSID. This detector, although designed originally for air delivery by fighter aircraft or helicopters, can be emplaced also by hand. It is a camouflaged seismic sensor, which, when activated by ground vibrations, periodically transmits a tone identification as long as the sensor is activated. This one is the Fighter Air-Delivered Seismic Intrusion Detector, or FADSID. It is a seismic sensor for detection of personnel and vehicles. It is capable of responding to commands originating from the Infiltration Surveillance Center or the monitoring aircraft. The commands can cause the sensor either to transmit activations immediately, store them for later recall, or reply to a status check. It is designed to fit in high-speed dispensers. The Helicopter Seismic Intrusion Detector, or HELOCID, is helicopter deployed. It can be launched by a retro-firing dispenser or by hand, and when emplaced is capable of responding to commands similar to the FADSID. The ground-emplaced seismic intrusion detector, or GSID, is essentially an air-delivered detector which has been redesigned for hand emplacement. It is smaller in volume and weight than the ADSID, but has improved performance characteristics. The ADSID components have also been redesigned for delivery by 81mm mortar. This is the mortar-delivered sensor, or MODS. Investigations are underway to develop the sensor to be delivered by light and medium artillery. Another example is the hand-emplaced seismic intrusion detector, or HAND-SID. It contains an internal geophone to detect seismic activity. In addition, it has a connection to permit the use of external detectors. One such connector is this magnetic intrusion device, MAGID, designed to detect the passage of ferromagnetic material, such as a rifle or truck. A later version, the Mini-SID, retains the same capabilities as the Hand-SID, but with 1/2 the weight. The other major type of sensor is the acoustic detector, which, when activated by sounds, not only transmits by radio an identification code, but also retransmits such sounds as the noise of passing vehicles and munitions detonating, and sometimes the actual voices of enemy soldiers talking nearby. One example is this acoustic sensor called an Akuboy, used to detect sounds of personnel and vehicles. It can be delivered by air or hand-emplaced. When air deployed, a camouflaged parachute guides the descent of the sensor. It is designed to catch in the jungle canopy, suspending the Akuboy above the ground to permit better sound pickup and to make it more difficult to detect. Another version is the Spike Boy. an acoustic sensor with a spiked nose permitting implant in the ground. These items can be hand or air emplaced. Other types of sensors incorporate combinations of sensing elements. The acoustic is a seismic sensing device with optional acoustic listening on command. All sensors, which are not intended for recovery, have provisions for end-of-life and/or anti-tamper destruct packages to prevent recovery by the enemy. Specialized air-emplaced munitions, such as these small camouflaged mines, have been developed to provide protection for sensors. They inhibit personnel movement off trails, deter construction of new trails, and discourage searching for sensors. Additionally, some sensors are booby-trapped. Other types of munitions are used along truck routes to immobilize truck convoys and to impede accompanying dismounted troops. As with the sensors, munitions have a predetermined end of life. This is accomplished either by self-sterilization or self-destruct. To produce useful intelligence, signals transmitted from sensors must be monitored and evaluated. This aircraft is used in the air-supported system as an airborne radio relay station to retransmit sensor signals to the Infiltration Surveillance Center. A supervisor's position has facilities for monitoring all channels on which sensor signals are being retransmitted. Selected signals can be recorded for later analysis. Four operator positions provide a backup capability to support the ground station, permitting operators on board the aircraft to monitor and analyze sensor information. The Infiltration Surveillance Center provides the central point for planning, monitoring, and managing the air-supported system. Information is maintained here on the location and identification of all sensors and minefields. All sensor signals are directed to a digital data computer, which immediately prints out a report of sensor activations. At audio monitoring positions, operators analyze actual sounds of enemy vehicles and personnel which have been transmitted by acoustic sensors and present a visual report on each signal. Target assessment officers plot locations of the sensors being activated and determine the direction and rate of movement of an enemy column, as well as its gross type and size. This information is correlated with weather reports and other intelligence information, such as known locations of rest areas and truck parks, to determine targets for strike action. When the surveillance system is ground supported, monitoring normally is much simpler. Each monitoring site often is responsible for an area within mortar or artillery range, and with sensors located in the general area of the monitor location. A portable readout device called a porta-tail has a self-contained very high-frequency FM receiver, a display unit incorporating telltale lights, and is battery-powered. The porta-tail registers identity codes from activated seismic and acoustic sensors and can receive actual sounds of enemy activity when used in conjunction with acoustic sensors. This device can be mounted and operated in a vehicle, aircraft, or small patrol craft using the carrying vehicle's electric power or the self-contained battery. Let's see how both air and ground-supported systems are used in a typical situation. For air-supported operations, intelligence personnel at the Infiltration Surveillance Center keep a constant watch over enemy activity. They plan the most lucrative locations for implanting of sensors and associated minefields. When actual locations have been selected, a request for aerial emplacement is made. Aircraft take off to deliver the sensors to the selected locations. After the sensors have been implanted and are in operation, actual sensor locations are plotted from photographs taken during the drop. This information is fed into the digital data computer. Then the air-supported system is ready for an interdiction operation. A North Vietnamese replacement unit is advancing southward, its dismounted troops infiltrating by a rather direct route into South Vietnam, as its supply convoys move down through another route. Activations from the convoy are picked up by the seismic sensors. These activations are transmitted to the airborne relay platform, maintaining its daily schedule in orbit 40 kilometers from the sensors. Other sensors are activated as the convoy proceeds en route. The detections can be passed verbally to an appropriate fire direction center or automatically relayed to the ISC for computer print. Every 5 minutes, the computer prints out an updated report. As the enemy convoy passes each acoustic sensor, an audio operator analyzes the sounds of the truck engines to provide confirmation and supplementary information about the type and number of vehicles. Output of the computer is rushed to the target assessment officer assigned to the particular area.
Sequence 1-9er appears to be moving at a fairly continuous rate. What do you make of it?
About 18 clicks an hour.
This computer report serves to confirm point-to-point movement, time, direction, and apparent size of infiltrating forces. Target information is passed to operations. After consideration of weather, other air activities in the area of interest, availability of forward air controllers and strike aircraft, strike requests are forwarded to the Airborne Command and Control Center.
Red Dog, this is Brown Bear. Request airstrike over area of sensors 20, 21,
Whenever
and
practical,
22.
targets are confirmed by visual observation by forward air controllers. Target confirmation is relayed to task force operations either direct or by communications relay through the Airborne Command and Control Center. When a decision is made by a command and control facility to divert airborne aircraft, the ABCCC establishes radio contact with the tactical fighters and relays all necessary target information, type and size of target location, direction of movement, and so forth. The designated fighter wing is directed to scramble alert aircraft when an airborne flight is not available for diversion to strike the target. Strike reports are analyzed at the Infiltration Surveillance Center as part of a continuing evaluation of system effectiveness and to aid in future planning. In a typical ground operation, intelligence reports have indicated the approach of dismounted troops of the North Vietnamese Replacement Unit toward Free World Force positions in South Vietnam. Positions for our infantry and direct support weapons are chosen to take maximum advantage of the terrain. Plans are made to implant sensors at probable avenues of approach within range of direct support weapons and within line of sight of monitor sites. Both seismic and acoustic sensors are emplaced by hand in the more accessible areas, by aircraft in the less accessible areas. With the sensors emplaced according to plan and their locations accurately known, personnel at each ground monitor site can begin operations.
We're all set at Bravo 17. Roger.
Sensor 13 activated, sir.
It's 0923 Zulu. Let's see if they stay on the trail.
Here's sensor 14 up, sir.
That's 0926 Zulu. I make it 3 minutes. Tell me when you stop getting activations on 14.
The officer determines, from the time elapsing between sensor activations, the pattern and speed of movement of the infiltrating troops. From the length of time which each sensor is activated, he estimates the probable number of troops.
Sensor 15 is up, sir.
Right on schedule. They're maintaining their same rate and staying on the trail. Let's get the Fire Directions Center on. This is Bravo 17. I have a target identified. Charlie is moving southeast down the trail into our position. Request pre-planned fire at position Alpha Charlie on my mark. Stand by. Ready? Ready? Mark.
Fire!
With the aid of sensors, Charlie's penetration has been detected and impeded. Aerial reconnaissance detects no further sign of enemy movement in the area. Sensors can be used in many ground applications: monitoring of landing zones, base perimeter defense, combat sweep operations, anti-ambush convoy protection, route surveillance, surveillance of enemy base camps, offensive ambushes, and targeting of enemy troop concentrations. Larger, more complex sensor arrays can be monitored at major command data gathering points. An aircraft is used as an airborne relay platform. Sensor activations are relayed by the aircraft to a mobile surveillance center, which is co-located with the Fire Support Coordination Center and the Direct Air Support Center. This mobile surveillance center provides timely information of sensor activations to the command data gathering point. Other support is also available. This gunship contains a portatail, which is monitoring ground-in-place sensors in an area which is inaccessible to artillery fire. An enemy reinforcement column is bringing up munitions.
Navigator to pilot, you'll have a target on sensor 2-3 at 12 minutes past the hour.
Roger. Take up a heading of 145 degrees. Your ETA is 1-1. Guns hot.
The elusive enemy has been located, stopped, and apparently badly mauled. Without the effectiveness of the integrated infiltration detection system, he might have slipped by our defense. This system is presently in use throughout Vietnam in riverine delta operations as a defense against waterborne interdiction and for protection of cities. Further, it has been evaluated for use in amphibious assaults, and presently is limited in its use only by the imagination of the user. Future developments are aimed toward more and improved instrumentation. Meantime, all reports indicate that bugging the battlefield pays off.